So in this video and subsequent videos, what we're looking at is the decision for how much is a business willing and able to sell. So the business has already decided what to specialize in. Now the question is how much to produce, and if they produce that amount, will it be cost effective? That is, given the price in the market, will they be profitable? When is a business willing to sell? When would they rather shut down? When are they profitable? When are they not? So that's what we're trying to figure out. And there's really two pieces that we need to dive into that. The first is productivity. So we need to look at how much is produced and how much bang we're getting for our buck. Okay, how much we're able to get in terms of production per worker is one measure of productivity, labor productivity. We also need to consider costs, and in our previous video we looked at variable costs and fixed costs, and now we're going to look at calculating those and graphing them. So we're going to be looking at productivity measures, so total product, average product, and marginal product. We're going to look specifically at the average product and marginal product of labor. There are other ways to measure productivity of marginal product and average product that consider other resources or factors of production. So you could look at the marginal product of your machines, for example. But we're going to focus on labor. And then we're going to look at costs. And we can measure costs in terms of total cost, total variable cost, total fixed cost. We can also look at our cost per unit produced. So we can look at the average total cost. We can look at average variable cost and average fixed cost. We can also look at the extra cost when we go to make one more unit. So marginal, if you remember from our previous discussions, just means extra. So the marginal cost is the extra cost to make one more. These are all going to be instrumental in deciding how much we're willing to produce and how profitable we are. So in order to dive into these definitions and calculations, what we're going to do is an activity. And so we're going to produce widgets. Now we're going to define a widget for this activity as taking a piece of paper, folding it once, folding it twice, and then stapling it. So must-have gift this Christmas, everybody wants a widget. Widgets are just made-up goods that we use to illustrate economic theory. If you are taking this course online, then unfortunately we can't be together to make widgets. And so you will see a video of some of your instructors at Red Deer College making widgets. And so unfortunately we can't make the widgets ourselves, but we can observe our employees, in this case your instructors at Red Deer College, making the widgets. Okay. So what we're going to do is we're going to work through an example problem from some students in a previous semester, and then later you will then use the ones from the instructor video to do similar calculations and graphs and help understand why those graphs have the shape they do. So we're making widgets. Now if we use data from a previous semester, okay, then in that previous semester, when the team was making widgets, we first had our capital, and our capital, remember, are the machines or tools. So in this case, our capital is the stapler, and we have one stapler here. And what we did is we hired 0 people, and we looked at how much was produced. Well, as you can surmise, if you have no workers, you're making nothing. Doesn't matter how many staplers you have. Well, then what we did with our Widgets Incorporated is we hired 1 worker. We still had 1 stapler. And in the class activity that was done in fall 2018, when we had 1 worker, they made 6 widgets. We then hired a 2nd worker, still 1 stapler, and collectively those 2 workers made 7 widgets. When we hired the 3rd worker, collectively they made 11 widgets, still 1 stapler. When we hired the 4th worker, those 4 workers together were able to make 13 widgets. And when we hired the 5th worker, then they were able to make collectively 15 widgets. We hired the 6th worker. they made a total of 15 widgets. So notice when we hired that 6th worker, it didn't add to our production. And then when we hired the 7th worker, our output went to 13. So total product, if we define total product, is the total output of any production process. So it's the quantity that is produced, and we're looking at it based on the number of units of labor. So we have our numbers of total product from the demo. So this is from a class that did it a couple years ago. And then you also have the one from the video of your instructors. And so you can do a similar table and similar graphs based on their output. Okay, so let's take this example here and let's graph total product. So we have our graph here, and we have number of widgets on the vertical, and we have units of labor on the horizontal. And let's see, we want to make sure that we have appropriate scale here. So I'm just going to make that 1, 2, 3, 4. Let's see, what do we have? 1, 2, 3, 4, 5. All right, 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, so let's graph the information that we have here. So when we had 0 workers, we had 0 total product. When we had 1 worker, it went to 6. When we had 2 workers, it went to 7. When we had 3 workers, it was at 11. And then at 4 workers, it went to 13. And then at 6 and 7, it was at 15. So let's try that again. At 5 and 6, it was at 15. 5 and 6 at 15. And then when we had 7 workers, it was at 13. So let's look at the shape of this total product. As we add more units of labor, right? So as we increase the number of workers, what happened to the amount that was produced? Well, we can see that the amount that was produced initially increases, right? The reason you hire more workers is so you can make more goods or services. Now, how steep or flat that is going to depend on how much extra is added by each additional worker. So that first worker contributed a lot, but notice that, so this is quite steep. When we added that second worker, they weren't adding as much as when we added that first worker. And so we can see the steepness here, depending on how much contribution each additional worker makes. Now, notice though, at some point, and for us, it's at 5 workers, we maximize the amount we can produce. After that point, when we add the 6th worker, they're not adding anything to the output. And when we add the 7th worker, we're actually paying that worker to destroy widgets. So would you hire a worker to destroy product? They're not adding any value to you. In fact, they're decreasing the value of what you make. So we would not hire this person here. Well, what about person number 6? Now, they're not decreasing the output. So if we have to pay that worker, though, they're adding cost. And so if you're not adding to the output, we probably don't want to hire you either, because you're costing us money without making more product. So after we hit that maximum amount produced, we really would not hire any more of these individuals. Okay, now, should we stop hiring before we hit that max? Well, that's going to depend on the cost of these workers and how much extra they provide. So we can't quite answer the question of what the optimal number of workers are, but we do know not to hire these individuals who are reducing our output.